Hello and welcome back to Higher Maths Differentiation Curve Sketching. So just a second example, just using exactly the same method as the first example. So first of all we are going to find the x-intercepts. So what happens here quite often is that you guys will see this. So rather than just thinking, oh, the x-intercept, the y-coordinate is equal to 0, so I'm going to write that 0 equals x bracket x minus 3 all squared. What you might do, and many pupils have done this before you, you might think, I'm going to expand this and then I'm going to factorize it. So you'd end up with x multiplied by x squared minus 6x plus 9, which would be x cubed minus 6x squared plus 9x. Then you'd look at that and you think, oh, I'm trying to solve that equal to 0. So you'd start factorizing it, and then after about 3 or 4 minutes you'll get back to what you started with and you think, oh, I've just wasted 3 or 4 minutes there. Okay, so it's already factorized here, so we can get the x-intercept straight away. We'll set y equal to 0, and then we'll solve either x equals 0 or bracket squared equals 0, in which case x minus 3 will equal 0 and x will equal 3. So there are our two x-intercepts, the 2 points where the curve will cross the x-axis. Now this is going to give a positive coefficient of x cubed, so I know that the curve is probably going to do something like that. Okay, so it's going to go up, do that, and do that. Remember, this may give a positive point of inflection, which is rising, flattening off, and rising again. But in this case, as there's two x-intercepts, that's not going to happen. So if we think about it, a positive point of inflection, there would only be one x-intercept. So it's going to rise, and then fall, and then rise again. But we do need to justify the nature of the stationary points. We can't just use that knowledge. The marks are giving for doing our nature table and identifying the maximum and minimum turning point in that way. Right, the y-intercepts, so solve, set x equal to 0. So substitute in 0. So 0 multiplied by bracket squared will just be 0. Right, stationary points. So this is the bit where what you may have done in the very first part of the question would come in handy anyway. So you need to expand your bracket before you differentiate it. Then we state that dy dx equals 0 for a stationary point. And then we're going to solve this. So we've got a common factor of 3 here, which is going to make it easier to factorize. And then solve each bracket equal to 0. Remember, if there's an x term at the front, x could equal 0. If there's just a constant, a number term, 3 cannot equal 0. 3 is just 3. So the only values of x for the stationary points here are 1 and 3. Substitute back into the original equation, the x bracket x minus 3 all squared. We want the y coordinate, so we substitute into y equals. So y of 1 will be 1 multiplied by 1 minus 3 all squared, which is 1 multiplied by negative 2 squared, which is 1 multiplied by 4, which is 4. And in a similar way, substitute in, but the bracket's going to equal 0 here, so we've just got 3 multiplied by 0, which is 0. So interestingly, that is the x-intercept, but that's okay. And then let's have a look at the nature tables. So we've got something happening at 1 and 3. So again, use dy dx in its factorized form. Pick a number before 1, which is 0. So we've got 3 multiplied by a negative multiplied by a negative, which will be positive. Check where my next stationary point is. Next stationary point's at 3. So I can pick 2 to substitute in here. So 2 minus 1 is positive, 2 minus 3 is negative. So we've got a positive multiplied by a positive multiplied by a negative, which would be negative. Double check for x equals 1, 1 minus 1, 0. So we have positive, then 0, then negative for the gradients. So it's going to be rising, flattening off, and then falling. So we have a maximum turning point of 1, 4. Repeat that process. So we've already done it for 2, so we've already got this bit. Substitute in 3 to the second bracket, we'll get 0, which is going to give a horizontal gradient, and then any number after 3, let's just pick 4. 4 minus 1 is positive, 4 minus 3 is positive. So we've just got positive multiplied by positive multiplied by positive to give a positive gradient. So there's a minimum turning point at 3, 0 because it's dropping, then horizontal, then rising again. It's a minimum turning point. And then put it all together on a diagram. So I've got my intercept 0, 0, 3, 0. So here to here, guys, is a distance of 3. So make sure 1, 4 is about a third of the way along there. It doesn't need to be exactly a third of the way along, but make it look as though it's not halfway along, basically. So we know that's a maximum, this is a minimum, and that is it all plotted. And remember, annotate your points. Just because they're written above, it still needs to go on the graph. Very important.